Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the event horizon here on Astronomy.fm radio. It is another Friday evening. This one is February the 1st, 2019, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal time, they'll put it at Saturday, February the 2nd, 2 o'clock in the morning.
2 a.m., yeah.
2 o'clock in the morning, yep.
Yeah.
And that means we are live for the next hour. And what do we do on Friday nights?
We take over the world, Marty!
There you go.
Gordon's alive, I tell you.
Hey, everybody, come on and join us in the chat room. Go to the homepage, astronomy.fm. Look down near the bottom where it says chat. Click on that. Join us. We've got you and me, Nick. We've got Starstorm, Glenn, and Cassie so far in chat.
Yeah. Now, just keep in mind, folks, the show will be available on YouTube. It will be posted on the AFM Facebook page. I will post it on my page. I will be posting it in quite a few places on Facebook. The nice thing is the AFM page is a public page, or the post is public, so that you can go there. You can get the YouTube video, which will have the links to the show. Thank you, Starstorm. It's always great to have you here taking the links. Makes my life a little bit easier, and I'm sure it makes Marty's life a lot easier.
Indeed.
So anyway, I want to touch on a subject that came up in Memorex a couple of weeks ago. We were Memorex.
Okay.
We were discussing Chang'e 4. And
yes, the rover on the far side of the moon.
Yes, and one of the comments that came up in chat was the fact that the people felt that China had actually stolen their technological leap in a generation. Now, I want to rebut this because the simple fact is the reason China has made their generation jump is because they're doing what America did during the Second World War on the Manhattan Project. They are literally importing the best brains from around the world. They're offering them the facilities, the budgets, and the opportunities they're currently being denied at home. Now, I did put a link into the chat room about this. This is another link. The original story I think I ran on the show about a couple of months ago, maybe 3 or 4 months back. And it was a CNN article. Basically, what China has done, it's decided, well, since the West is not bothering to fund big science anymore, we are going to do it. And one of the things China is doing as part of their technological leap is they are working in hand with foreign universities. Now, one of these places that is doing this is the University of Liverpool. And so what happened was a couple of scientists from the University of Liverpool were commuting between China and the UK with their astronomical colleagues over there. Actually, if you read through the story, yes, a lot of it's about medicine, but some of it is also about astrophysics and astronomy. And then a couple of the scientists were offered a chance to be in on the new telescopes the new radio telescopes and some of the new optical equipment that the People's Republic of China were actually putting in. Now, in the West, we have we have decided to give up in a lot of cases the idea of being an innovator, of doing cutting-edge science. A lot of countries, no names mentioned, have actually cut back science spending to where it's actually a joke. And China says, hey, that's fine by us. If you want to come and work, you can have good living facilities, very good pay. We'll give you a VPN so you can enjoy Instagram and Facebook and do everything you can do at home. So a lot of these scientists are taking these opportunities. One of them is an astrophysicist, Theodosius Kovarvan, who now works at the Zayan Jiatong Liverpool University project. And he says the language has proved his biggest challenge, but over 7 years, his Chinese has improved, and it's been easy to miss important small print in large documents. However, as he found out by using his students to help him, the lack of Chinese language and written skills has been circumvented. Like any true scientist, where there's a problem, he's found a way around it. Now, of course, a lot of the Chinese scientists also speak very good English. It's a required language. That's why there's so many Americans and Brits over there teaching it in schools. China believes that it should be a multi-language country, even though it prefers Mandarin over Cantonese and other dialects. That's not the point. The fact is they put their money into teaching their students English on how, and giving them the skills to interact with their colleagues abroad. So my rebuttal is the technology that allowed them to put taikonauts into space, and to put a rover on the far side of the moon, which was a project NASA itself wrote off as being technologically unfeasible and impossible.
Putting a rover on the far side of the moon?
Yeah.
Really?
And then communicating.
But maybe I can't imagine impossible, but maybe not in the budget.
Well, it wasn't just in the budget. The actual all the things you have to put into place. You have to have a satellite.
But yeah, there's been
orbit.
Talk of that since the 70s about doing it that way.
But nobody wanted to do it. But
Right. Not that they couldn't do it. They just didn't want to do it.
But anyway, the thing is, yes, scientific espionage happens in every country around the world.
And it's not always espionage. Sometimes it's just, we're going to let you do what you want since you don't want to participate with us, and we're going to do what we want, and we'll share information amongst ourselves.
Yeah, exactly. If you take a bunch of astronomers, I talk to Chinese astronomers, I talk to Japanese astronomers, I talk to Korean astronomers. We share information and ideas. A lot of cases, it's on social media.
Mm-hmm.
We all get to know each other on social media. We post stories about science and stuff, about our interests, like comets, for me, comets and the moon. And the information gets picked up and it gets shared. So basically, scientists are doing what scientists would always do. They will talk to their counterparts and share theories, share ideas, share information without breaking any particular law that says thou shalt not say about this.
Mm-hmm.
NASA published everything, every scrap of information about Mercury, Gemini, Apollo, the shuttle, Skylab, etc., etc., etc. The only people who really clammed up a lot of the time was the Russians, which is the Russians for you.
Mm-hmm. Mm-hmm.
And so why shouldn't places like China and India pick up this information that's free, that's openly put on the net, and make good use of it?
Mm-hmm.
And I think you'll agree with Marty, we've always believed that if we're going to go to Mars, if we're going to go to Saturn, Jupiter, to Pluto, it's going to be a multinational effort, because no one country can afford this type of mission anymore. It's beyond a single country, really, in modern times. But by working together across frontiers, we can build the equipment, we can fund it, and we can do the missions. We have the people to do it.
But we're also getting a little bit of the opposite, too, where we're getting multi-individual companies building rockets now.
Yeah.
Independently. So some of them, just by competition, may also be, instead of cooperation, but by competition, may also accomplish these tasks. So it might be a private company that actually gets to Mars with people before it is a multinational cooperation. It's just variable. It goes back and forth.
Yeah, it goes back and forth. But the thing is, it no longer has to be a national agency that does everything.
Right.
And that perhaps is the biggest quantum jump that we've faced in our lifetime. Don't forget, we have gone literally in a very short period from the early days of flight to space flight. One of the Wright brothers was still alive when we started launching rockets to the moon with people on board. So they have seen it all. They literally have seen their canvas string aircraft starting off as the pioneers, and they've seen us making that first step into the future with that first lunar landing and Neil Armstrong and Buzz Aldrin walking out onto the lunar surface.
Well, my grandmother was basically lived that space of time too. She was born in the late 1890s and died, I think, in the 1980s, 1990s. Also, she was close to 100 when she died. So I remember she telling me that before airplanes and stuff like that, her grandmother told her that people can't fly, only the devil can fly.
Yeah.
Well, they wouldn't believe airplane flight, and then she lived obviously to see the moon landings.
Yeah. So the thing is, technology has taken us a lot more steps, a lot quicker. As Glenn points out, his granny grew up in a horse and buggy times. She saw the motor car. She's probably seen space flight and everything else. So once technology gets a kickstart, it takes just few people to start the process with their early experiments. Even Da Vinci was designing helicopters,
right?
Even before we could even fly, and that was considered the devil's work back then. But as I say, the thing is, we can't say that country X stole this from country Y. Everything you want to know about space flight, about spacecraft design, and spacesuit design and medicine is out on the internet, freely available, no matter where you live or what your country's politics is.
More now than in the past. That Russian shuttle.
Yeah, that was kind of sad, really.
That looked like pretty much stolen technology there.
Well, so was the the Tu-144. It was the Soviet version of Concorde, but someone caught on to the fact that someone was trying to steal the design, and they doctored the specs and everything. And unfortunately, the Tu-144 on its maiden flight, the propaganda flight as well, fell out of the sky, kaboom, because the plans they had for Concorde had been fixed.
Adjusted
nicely.
Adjusted. Yeah. Politically we'll call it adjusted.
But anyway, the thing is, you don't necessarily have to have used espionage to have gone in one generation from a backward country to a high-tech country.
Right.
It's available. It doesn't take 20 minutes to go on the internet to do a search how to build a rocket, how to build a light support system.
Sometimes it's just you buy one and reverse engineer it.
You can do that too, and I'm sure there's plenty of places. You can still buy Apollo hardware, bits and pieces of Apollo hardware. My good friend Nick Howes, he collects the stuff. There are people who collect it, and a good engineer can go into something and figure it all out very easily. I hate to say it isn't rocket science.
I knew somebody that worked in some part of the Apollo program, and he said he still had leftover relays that were the type that were used in the Apollo mission. Maybe not the exact ones scheduled for it, but they're basically standard relays that were used during that time.
As I say, the learning curve for Mercury, for Gemini, for Apollo was a very steep one. But we did it because there was the determination to do it. And that's why I think we are now we now have, which is, this is utterly brilliant. We have a load of nations who are able to provide launch facilities. India is working on its own manned space flight. Yes, a lot of the technology I've seen on the posts about it does look like Apollo technology, including the escape tower equipment.
Well, some of it has to be. I mean, you really need an escape tower on your capsule, because the same thing can go wrong on yours that did with everybody else's. So you kind of learn from not only your mistakes, but you learn from everybody else's mistakes too. There's only so many escape tower designs you can build, and they're going to be pretty similar.
Yeah. Now, there's a couple of other things that have happened in the week. Let's quickly go to something that happened today.
All right, what happened today?
A space rock hit Cuba.
A space rocket hit Cuba?
A space rock hit Cuba.
I didn't hear that
to have
one.
been a meteorite has actually struck the western Cuban town of Vinales, according to local reports. There is actually a filmed contrail. There was a sonic boom, and they are finding decent-sized chunks of rock on the street that weren't there before.
Nice.
So I put the link. And some people were even picking them up in the backyard. And I'll be honest, the Cubans were not pointing the finger at the US straight away. Because it said was, from everything they had seen, it was a meteorite that had burnt up. Even the National Weather Service picked it up crossing Florida. People saw it cross Florida.
Nice.
So even the Cubans knew it wasn't something launched from the US.
Mm-hmm.
The trajectory alone. So, as I say, for Cuba, that was an exciting moment. There's a big picture of the trail left by the presumed meteorite, and there is a little movie. I don't know about broken windows yet, Cassie. I do know there's no loss of life or no injuries so far. Mm. But as I say, it's one of those things. We had the Chelyabinsk airburster that did cause injuries to people. It cost a lot of damage to buildings. Mm-hmm. Again, it's one of those things. We will get these things that sneak through. They come in from unexpected trajectories.
Mm-hmm. I gotta talk to one of my geology contacts, and sometimes he knows the right people that will get samples of that. So I'll have to put the word into him and see if I get one. I got one in Chelyabinsk that way.
Yeah, I bet that the Cubans will be wanting to have everything analyzed, and everything credited. So no doubt they will be going to the best people. I do understand that from BP that Jeff Notkin, who's in Tucson at the moment, has been told about this story
cool.
Via Twitter. So I'm sure
if you get a lot of particles like that, they do end up being sold, and at least semi-partially reliably you can get one of those if you know the right people.
Some of these pieces, Marty, are the size of a Samsung S6. They're big.
What's that?
They're big. So Samsung S is a large size mobile phone.
Okay.
And there's actually a picture of one of them sitting on an iPad.
Yeah, I see that. Yep, there's pictures of it on that link you posted out there. Yeah. So, yeah, one that's actually cracked in half, and they got both pieces recovered too.
Yeah,
that's kind of cool. So that's some nice pieces, palm-sized.
Yeah.
And they look like the ones they're posting actually look like meteorite fragments that I've seen before too. So less chance of being fakes, but you still got to get a good, reliable source if you want to purchase one of these.
Yeah,
I'll see what I can do.
I'll be keeping an eye on the Aerolite website to see if Jeff or Steve comes up with anything. Now, my final rant for the night is concerning journalism.
Okay.
Junk scientific journalism. It is an absolute mare. This is a link from the Daily Express, or the Daily Fail in my book. I'm sorry. The leader was NASA asteroid tracker. A monstrous asteroid is going to either swing around the planet or hit the Earth. Now,
was that Bennu?
Yeah. No, it's not Bennu. No, this is actually BC 20. Because I was actually talking to Guy at the Northolt about this, and Lauren Ball about it. Lauren actually posted the story in one of the amateur astronomy groups on Facebook. BC3, that's it. Now, JPL says that BC3 is about 8 times longer than a London double-decker bus. Something in the likes of 101.7 feet to 226.4 feet, 31 to 69 meters in diameter.
Okay.
So, this is 30 times longer than a queen-size bed and 17 times longer than a Volkswagen Beetle. Now, of course, they've got this really clickbait story about the fact their picture shows it as if it's going to impact the Earth. Or, I'm sorry, it's just the biggest load of piffle going. It's actually, this object is already down to Mag 20. It's that faint. It's come and gone. But journalists hyping stories like this, on not only on their website but in their papers, is what causes an awful lot of concern, because people then start believing the Feldergarb about astronomers lying to people about what's coming to hit the Earth. In fact, the biggest one I've recently been tracking story-wise was about our old friend Apophis. Now, the thing is with Apophis, this has now had a much, much better orbit worked out. Yes, around 2023 or something, it's going to come close to the Earth.
But close is relative.
Close is relative. However, they're talking about originally about 2034, about it being an impactor. Well, guess what? Not going to happen.
Yep.
The Minor Planet Center and NASA have worked out this orbit so well now that this is going to be one of those pieces of rock that it's not going to be a threat to us. It may make a nice bit of mining real estate in the future, but it's going to come by, it's going to zip past the Earth relatively soon, and then as I say, the old danger date was 2034, and now not going to happen, dude.
Yep.
You're going to need to start smoking some more of that stuff if you really believe this is going to happen.
I get an article like that too after you're done.
Yep. But as I say, journalists need to get their facts right. They need to speak to astronomers. When they put stories like that out in newspapers, on television channels, given the amount of, that's fake news, that we hear about truth.
A lot of it's half-truth, sort of.
Yeah.
Too,
But
giant asteroid whizzes by Earth. Well, define whizzes by. Well, yeah, they're moving fast, but by depends on how much you consider close and how big you consider giant. A rock too big to pick up would be giant, but it's not that really big as far as other ones go.
But the thing is, BC3 is at 1.2 to 1.5 lunar diameters out. It was never a threat, people.
Right.
It's only because some idiot of a journalist who published the NASA information and then completely wrote a headline that's so misleading, it's not funny. I was talking to a friend of mine in Canada, Kirk. He lives most of the year in China. He comes back to Canada for a few months every year with his wife, and he said something. He's going on about, I could start a really good conspiracy about Changi 4. I said, please don't do that, because at the end of the day, it's people like me who have to debunk it, and people believe it because they don't want to believe the truth. They don't want to believe we could actually do this. It's so stupid. People still don't believe that we went to the moon back in the 60s.
I know.
1969 through to 1973. We did it. We left the equipment there. LRO, JAXA, and even one of the first Changi probes imaged that site. They have imaged the lunar landing sites of the Apollo missions. And let's face it, folks, if it was a fraud mission, don't you think they'd be plastering their headlines? NASA lied. There'd be a picture of supposedly of the landing area, nothing there. But the pictures show the landing site. You can see the blasts from the engine. You can see where the experiment sites are. On the later ones, from 15 onwards with the lunar rover, you can see the tracks from the lunar rover, from where the astronauts took their first beach buggy trips around the moon. They are clearly visible. The tracks left are visible from a space probe when it's taking images around the moon.
Yep.
JAXA has them up in their archives. LRO has them in the archives. And as sure as whatever, the Chinese have pictures of those sites. And let's be honest, if anybody is going to call the American government out, it's going to be China and Russia. Russia never called us out over the American government over Apollo, because they agreed that the Apollo missions had worked and that they had landed on the moon. That's why they never bothered anymore to want to go to the moon. The Americans had already beaten them. What's the point? But they could have still made a propaganda coup by exposing a fraud. They didn't.
As far as big rocks flying by the Earth, I've got one that will really, really scare you. No matter where you live, no matter where on the Earth you live, every day there's a rock that's over 2,000 miles away that flies overhead and just barely misses the Earth.
The moon?
Yep. It's just a matter of how you word it. Same thing with this with this rock, that's the same size as the Earth. Flies by the Earth only 30 million miles away from us every year. You know what that one is? That's Venus.
Oh, Venus, Mars.
Yeah, that's Venus. Yeah, that's Mars. Well, Mars is half the size of the Earth. This one, Venus is the same size as the Earth. I had this one too. That there was the thing in the obviously on the internet, whatever, a giant solar flare blasts off the sun last week, and if it hit us, we would have been vaporized. Well, that solar flare was not that big. It was from a sunspot. Yeah, there was actually a sunspot last week. There was kind of a group. Yep. And just as it hit in the edge, it actually, part of it grew into a fairly nice size. And right on the edge of the sun, I reported this, I think last Wednesday, that it had a flare. So it would have been really great for hydrogen alpha telescope viewers. Look at the sun a few days ago when the sunspot hit the edge. It did flare up. I think it actually flared when it was around the far side of the sun. And it was the biggest flare in a couple of months, but it was what's called a designated C5 type of flare, which is pretty much an average small flare. If that flare was facing directly towards us when it went off, it would mean nothing. It'd be just nice to look at. It might have sent a little bit of extra particles to give us some more northern lights, but maybe not. So that's during solar maximum. C5 flares go off all the time. They're facing directly towards the Earth, and we don't get anything except maybe a little bit of extra particles from the sun that might cause some auroras down about my level of 45 degrees latitude. So it was like they blew it up to something really big, and it was not.
Hey Marty.
Yeah.
I've got another one for you.
Alrighty.
Okay. Again, it's from the Daily Fail. Scientists have discovered a supermassive black hole at the center of the Milky Way, which is pointing its radio jet emissions directly at the Earth. I'm sorry. I gotta share that one. Come on, Daily Express, you are so useless. Come on, guys.
Well, by the way, if you want to avoid getting hit by a meteorite, just go live down around where Glenn lives or Black Projects lives, because they have an official astronomy.fm hard hat guaranteed to prevent you from being hit on the head by a meteorite.
Okay, so what they're saying is Sagittarius A, which is supermassive black hole at the center of our galaxy, is unleashing radio jets. Okay, that's true. Which are pointed directly, almost straight on towards the Earth. Maybe. This is where I think that they are getting rather silly.
What that article is? Let's see if I've got a copy of that. Let me post it in chat if I can find it. What they've done is actually increase the our ability to observe the giant black hole in the center of the Milky Way galaxy by basically improving instruments. The ALMA radio telescopes and a few others around the world combined together. They're using some higher frequencies, so they're getting some better detail of that area around the central black hole, and they're finding they can actually see into a smaller area. So instead of this like big blobby light coming from there, because there's a lot of gas and dust in between us and the black hole, that it's actually kind of scattering the light. So we can't get it resolved down that type. But recent improvements have been able to resolve it into a smaller viewing area around that black hole. And they said because of that, we can see it a little bit tighter around there, that a couple things are happening. One of them is potentially that there might be a jet coming out of the black hole that's facing towards us. Because it's facing right towards us, that means we're seeing it in a smaller kind of point of light instead of having it slightly off, which would make it appear a little bit bigger.
Now, the other thing they're saying, according to this, it's pointing 3 millionths of a degree away from the Earth.
Yes.
Over that distance, 3 millionths of a degree is it's going to expand. I'm sorry, if it was pointing dead on bullseye, then yeah, that's something to worry about. However, you have to remember that the way things go, and shame Red Shirt 3's not in here because he would be very useful for this.
Here's the I'm putting it in chat, the link into chat.
Yeah. By the time the jet reaches us, we'll have moved. So this is Marty's link is probably the more accurate, given the sort of the scare story from this newspaper.
Mm-hmm. Yeah, my article was basically what I said. They've just basically improved the resolution of the instrumentation so that they could actually see a little closer to that black hole, reduce some of the scattering. That makes it a little bit more fuzzy.
Yeah, it kind of worries me if this is a national tabloid. And they used to be a very good newspaper once upon a time.
Really?
Yeah.
Yes, but they weren't selling as much that way, so they had to hype it a lot, I guess.
Oh yeah. But
as I say, we have fun hyping some of the stuff too, just for fun.
I know, but you know what? We do actually try to give factual information about it as well.
Yeah. Well, when we hype it, it's a little tongue in cheek.
Exactly.
Hyping something that's real basic, like that Sun article.
Yeah. But anyway, so this is something I'm seeing a lot more happening in the media. Is that, as for instance, there was
wait, something that we have to hype right now. It's extremely important. If we don't do it right now, the world's going to end, and that is. You're listening to the Event Horizon here on Astronomy.fm radio. It is now approximately 9:30 in the evening on the eastern portion of North America on February the 1st, Friday night, 2019. Saturday morning, put it about 2:30 in the morning, Universal Time, again, 2019. So we're halfway through our program. And don't forget, we'll repeat this program and more programming every 4 hours for the next 24 hours. So stay tuned. And, of course, we invite you to join us in our chat room right now. And just go to the homepage, astronomy.fm, and log in there. It's real easy. And ask us questions about the entire universe if you want to. We'll try to answer it. So we got, so far in our chat room, we got you and me. We got Starstorm, Glenn, Cassie, and Black Projects. I did it. So the world won't end.
Yeah. Now, I actually, when I first logged in this evening, there was somebody in chat called Schrödinger, and they actually spelt it with the accent in the right place.
All right.
I was quite impressed by that. Someone actually knows how to spell Schrödinger properly.
Mm-hmm.
Anyway, Glenn asked about
Schrödinger.
Schrödinger, the physicist.
Is it L in there?
I
think it's Schrödinger.
SCHRO with the accent D.
DINGER.
I think it's LGER. Anyway, the fact that it's.
Let's look it up. I'll look it up.
It's
Go
the
ahead.
guy with the cat. Someone's asked me, is that the guy with the cat? Yes, it's the guy with the cat. And actually, there was quite a few interesting backstories about Edwin Schrödinger.
Schrödinger, no L in there.
Oh well, he got very close.
No, he got it right.
Yeah, he got it. See, I told you.
See,
you didn't believe me, did you?
It's Schrödinger's cat, not Schrödinger's cat.
Anyway, Glenn asked about opportunity, and we
yes,
go to opportunity. So there's a link.
Got an article. You got a link? Because I got one from NASA too.
I got one in there already.
Okay. From NASA?
This is from space.com. Opportunity's been there on Mars since 2004. Interesting fact, it's warmer on Mars than it is in upstate New York and Wisconsin and Michigan right now. So there's a scary thought for you.
I believe it.
Anyway, so it's supposed to have lasted 90 days. It's done a marathon 26.2 miles or 42.1 kilometers since its landing. And the last time we heard from it was on June the 10th of 2018. Now, one of the greatest scientific findings was the fact it confirmed the presence of standing water on Mars. It uncovered the presence of hematite, gypsum, and other rocks, which tend to form in water on Earth. It also found evidence of an ancient hydrothermal systems, and Opportunity demonstrated it was possible to operate a rover for more than a decade on another planet. It's overcome engineering, driving issues as it continued to work. Now, it fell silent during a global dust storm that swept across Mars in June of last year. The rover does require solar power for operations, and during heavy dust storms, there's just too much in the air to get sunlight to its solar cells. As of mid-August, the dust has begun to clear, and JPL initiated recovery operations for Opportunity. Now, it's been approved for an extension till October the 1st of 2019, assuming that the rover is recovered as planned. The Opportunity team is also preparing a new 3-year mission that will be submitted to NASA for competitive review against other missions. Regardless of whether it is recovered, Opportunity has generated a huge legacy, and it will continue to work with NASA's Curiosity rover, still active as of August 2018, and the upcoming 2020 rovers. The twin rover was Spirit. It was developed as part of NASA's Mars exploration program. NASA has been sending missions to the Red Planet since the 60s, with some of the most prominent missions including Mariner 9, the first orbiter, Vikings 1 and 2, which quite likely did contaminate Mars, the first landers, and the Sojourner Pathfinder, the first rover. Now, in the last 20 years, NASA has focused on sending a Mars mission as often as possible, which means every 2 years at the time, Earth and Mars come relatively close together in their orbits, which is when we all tend to be busy trying to image Mars at the same time. So, the goals of the rovers to determine if life ever arose on Mars, focusing particularly on ancient water and characterization of the climate and geology. That they have done. Now, the other big long-run mission is a Mars Reconnaissance Orbiter, and that will be no doubt used as part of any other future mission to the Red Planet. The rovers received their names from 9-year-old Sophie Collis. Sophie won a competition naming contest with the assistance of the Planetary Society and sponsorship from Toymaker Lego. Why am I not surprised that Lego's involved? So they were launched in 2003, Opportunity on July 7th, and Spirit on June 10th rather, aboard Delta II rockets. They undertook a 283 million mile journey to hunt water. They did it. They found the presence of ancient water. They had a suite of instruments, including a panoramic camera, a microscopic imager, engineering cameras, 3 spectrometers, a rock abrasion tool, and a magnet array. And of course, they had a small arm that allows them to get close-up pictures and data from interesting targets. The other thing, of course, was the layer of hematite. That's what really intrigued NASA. It was found by the orbiting global surveyor and located on the Medini plenum at the Martian equator. And that was what was decided to be Opportunity's landing site. Because the only time you get a hematite, which is an iron oxide, is in a region that has had water. So the 384-pound rover made its final approach on January 25th, 2004. It ploughed through the Martian atmosphere, popped out a parachute, and then vaulted to the surface in a cocoon of airbags. It actually rolled to a stop inside a shallow crater, about 66 feet across, delighting scientists with the first pictures that beamed back from the Red Planet. Let's face it, there has been a hoodoo concerning Mars and Venus. One mission completely missed and went into a solar orbit because of the mismatch of units used. One thing was using in scientific international units, and the other one was in good feet and inches. Why are we not surprised the mission failed?
So the latest article that I see from NASA is that they have been trying to contact it. In fact, they tried 600 times over the past 7 months, and they haven't heard back from it. So they're constantly trying to at least ping it and say, okay, send back a quick signal. Now, there's a couple things that could be wrong. One is that its primary radio failed.
Yeah.
Maybe its secondary radio failed also, and maybe the internal clock is offset. So a couple things, if the internal clock's offset, the computer's not setting right, it might be working but pointing its antenna at the wrong position in the sky because it thinks it's at a different time than it should be. So any one of these little things could be going wrong. Now there is a chance that maybe some dust has settled on the solar panels, and there is a time of year on Mars, which is right about now, when the winds increase and they could clear the panels and get those batteries charged up. But we're kind of running out of time. It's getting towards Mars winter, and they don't think the batteries have a chance of surviving freezing conditions uncharged. So they're going to keep trying, and they are trying regularly. But so far, no luck. So hopefully they could get just a signal to it that says, turn your antenna to the left and listen, and maybe we contact it. But they're still working on that. But so far, no luck.
Now, Glenn asked a question in chat.
Okay.
Is Curiosity nuclear powered? Yes. Very sweet answer. So, it has a nuclear generator. And it's the multi-mission radioisotope thermoelectric generator, or MMRTP. Marty, you can take over a second. I've got a cough.
How much?
Okay, sorry, I was asking you to take over. It's what it does. It's an energy source that relies on heat generated by decaying plutonium dioxide. It's designed to run at least one Martian year, which is about 2 Earth years.
Neat.
It is. It delivers both heat and 110 watts of steady electric power from an array of iridium capsules holding a ceramic form of plutonium dioxide. So the heat is piped through Curiosity, carried by the liquid Freon. Thermoelectric devices on the generator convert the heat into electricity with no moving parts. This was actually built in the Idaho National Laboratory.
As I say, you also have one of those things, by the way, in most of your furnaces, called a thermocouple.
Yeah.
It sets a little wire that sets into the pilot light, generates a little electrical signal, and that's sent to the thermostats, which opens and closes your gas valve. So yeah, basically, except they're using radiation instead of a natural gas flame.
So basically, nuclear power has been used in 26 previous space missions over the past 50 years. One of the jobs the Idaho National Lab team have is that they actually assemble the power source and they test it for vibrations to simulate a rocket launch conditions, making sure that the generator's electric field won't affect onboard scientific instruments as well. So the thing is, this is what keeps Voyager alive and ticking. It's a nuclear battery. And they are still these probes are right on the edge of the solar system. They have been out there since the 80s, and they are still going strong. Yes, some of the experiments have seized up and may not be operating, but we can still contact, and we are still getting science specifically from Voyager 2. So Voyager is still alive and kicking and talking to us.
All right, let's see. Meteor showers, we've got some this time of the year, just a few of them. They're all seem to be hovering around the beginning of February, starting with February 1st, the Alpha Antilids meteor shower peaks. February the 3rd, the February Epsilon Virginids are peaking. On February the 4th, the February Eta Draconids are peaking. On the 6th, the Pi Hydrids peak. And on February the 8th, Alpha Centauri meteor showers peak. So basically, this is kind of a hot time of really poor meteor showers, if you want to put it that way. There's a lot of them that are not producing a lot of action, but there's, what's that, about 6 meteor showers or so happening right now.
Now, has anybody been out in the mornings around between 6 and 7 o'clock?
I don't get up early in the morning in cold weather like that. No, but I have been on my star chart, and I see that is some pretty nice planetary stuff going on there early in the morning.
Well, yeah, I've been capturing Venus, Jupiter, and the Moon for the last couple of days on my mobile phone. In fact, let me see what I can do. Let's see if I can get away with this.
Saturn, Jupiter, Venus, Saturns are all in the early morning sky, and the moon, crescent moon's been slipping in amongst them too. There was a really pretty close conjunction of Venus and the moon, which I didn't get a chance to look at because of the cold weather and stuff like that. But actually, the more prime time was not early in the morning, but later in the morning. For me, 11 o'clock in the morning would have put Venus and the moon in the southwestern portion of my daytime sky, and that would have been quite easy to see with one of my telescopes if I'd set it up in the daytime and actually look for them. But
anyway, so I just put a link into the chat room. That is the picture I took, I believe, this morning, with Venus high up and the waning crescent moon just about to slip over the back of the house across the road from me right now.
So
I've been good.
There you go. Where's the? Oh, there's Venus way over there. Okay, so yeah, that's gone a little bit past. They're actually within about a degree of each other.
Yeah.
Yesterday or the day before, or something like that. I can't remember which one it was.
And I did get the last 3 days, so I did post them on my Facebook page. I think quite a few people were surprised.
It's one of the reasons I hate living in the middle of a city, because I lose not only the dark skies, but I lose even the brighter stuff amongst the buildings.
Yeah. But as I say, I'm mostly up around 5:30 in the morning. Particularly now, I tend to get up a little bit earlier because I've got to get sorted, get out, start the car. So yeah, I'm getting to see these things, and it is quite nice.
They're nice. Yeah, that thin moon's nice with the planets.
And as I say, 3 days ago I had Jupiter, Venus, and the Moon, and this morning I just got out in time to catch Venus and the Moon. So that
means this weekend, everybody, is Deep Sky Observing Weekend, because the moon is pretty much right around new moon.
Yeah, it's getting there.
Yep, so no moon interference if you want to observe those galaxies and star clusters and gas clouds and things like that, the sky.
Well, to be honest, I'm on an eye telescope and stuff. I'm going to say this once. You can still do one-shot galaxies and nebula on eye telescope. Now you've got to write your own program to image comets.
Oh, do you? To follow them? Okay.
To image them, yeah.
And you never had to do that before, or you just
never had to do that before, because they used to have one-shot comet, which was very convenient for me, and I could go hit a comet up very, very quickly.
So they had a dedicated comet telescope, is what you're saying?
No, it wasn't a dedicated telescope. Basically, when you go onto you pick a telescope platform on eye telescope, and when you go in there, when it's loaded, you'll have a series of options. One is one-shot deep sky, one-shot comet, and then you get all your other options where you actually sit down and write a little program to actually run the telescopes in ACP. Okay. Now, you still got one-shot deep sky, but you now have to do your own comet program. From what I can understand, and I'm going to tell you that the guys at Eye Telescope have been brilliant. I've been trying to get Ayamoto, and I've been using their one shot, and it kept crashing on me after 9 lines. This was their own script. So you got to write a script, and so they've changed it a little bit. They did have a live workshop. Now let me just quickly scan down because I can find that, and where they actually went through all the new changes.
Oh, okay. I'm sure it's on video now too, though.
It's on YouTube, yeah.
On the same and linked through their website of itelescopes.net.
I pulled it up. Let me just.
It usually is. They're pretty good about explaining their equipment and how to use it and stuff like that.
Yeah.
Videos and things like that. By the way, everybody, we got some solar activity, increased wind speeds, and increased density coming from the sun. So high latitude observers can be expecting some pretty good aurora. In fact, there's actually been some pretty good aurora. They said best of the most recent times of aurora have been showing up. It's like, Scandinavia, stuff like that. So keep, if you're pretty high up there in latitude, keep looking for some decent auroras. Get some stuff. Nothing down, 45 degrees, not considered a high latitude where I'm at. Not necessarily the 55 where you're at either in the UK, when you're in the UK.
Well, as I say, UK is further up towards the pole, so we get the chance of more things. Having said that, it's also very much weather dependent.
Oh, yes, of course.
Oh, here we go. I found it. I'm pulling up the link right now. Okay, I'm just going to grab that link.
Go ahead. I got one more quick thing. A newer supernova, only about 13.5 magnitude, has been reported in the galaxy NGC 3254. The supernova designation is 2019 N as in Nancy, P as in Paul. So if you look that up, you can get the coordinates. I think it's somewhere, if I looked this up before, somewhere around the Sombrero Galaxy.
Nice.
Mm-hmm. So good for you astrophotographers using the itelescopes.net telescope system.
So as I say, there are other telescopes out there, but iTelescope are really good. You pay a subscription fee, and then you get to...
It's not too expensive either.
It isn't really, no. I quite like it. I use it a fair bit. I'm just trying to get logged in so I can check something. Okay. But as I say, you set up a username, you pay by the month, you get X number of points, and you use those points for your imaging runs. And then they'll send you an email with everything. In fact, I mean everything. You get a complete log of the program that was used. You get to see the weather for the telescope you're using. You really can't go wrong with them. I have to say that you really can't go wrong.
Go ahead. I got one more. I got a black hole, since we're on the Event Horizon article.
Yeah.
Want to pop it in?
Yeah, pop it in.
All right, pop it in the chat room here. Okay, what it is there again? Better equipment, just seeing more stuff, and this is some NASA's NICER mission has mapped some light echoes of a fairly newly known black hole. Was just discovered several months ago because it basically flared up. While using some improved equipment, what they're actually being able to tell is they're being able to see not generally just increased light from the black hole, but they also can tell that the increased light is coming from next to the black hole. And this black hole is about 10,000 light years away from us. So improved equipment is actually being able to see more stuff around black holes, and that's pretty cool stuff too. So basically something in the black hole flares up, and then it actually hits the material that's surrounding the black hole. And there's two different types of stuff surrounding the black hole. There's that accretion disk, and then they think there's like a kind of a corona around the black hole also. So basically particles around it that are getting energized, and they're being able to tell the difference between stuff that's not just falling into the black hole and getting lit up, but they can actually tell that there is stuff around the black hole and in, say, a corona or an accretion disk. And the article's in our chat room.
Yeah, I'm looking at this right now. There's a nice little video that goes with it. So it's in Leo, and it was okay. So they're talking about how the black hole can siphon gas from a nearby companion into the accretion disk.
So obviously it's a binary system.
Yeah, and they reckon that there's the region of subatomic particles around 1 billion degrees Celsius.
Mm-hmm. So basically, they're different frequencies of X-rays that they're actually looking at.
Yeah, it looks. This is work being done at the Massachusetts Institute of Technology, Kavli Institute for Astrophysics and Space Research in Cambridge.
Mm-hmm.
The corona is still pretty mysterious, but we have a loose understanding of what it is. And now we have evidence that the thing is evolving in the system is the structure of the corona itself. There was a decreased time lag, which was due to a change in the corona, not the disk. So they're using a signal called the iron K line, created when X-rays from the corona collide with iron atoms in the disk.
Now, we were talking about Saturn and the moon. I wonder, there was Saturn. The moon actually went in front of Saturn. Says today, but that might, since it's already February the 2nd, it might have happened a little while ago. I'm trying to figure out. The moon's past Saturn right now, so I don't know when that happened. It looked like a yesterday thing, but it says it was today. Visible only from about Central Europe, Western Asia, maybe a little bit of Northern Africa. That it actually happened. But it's always nice to see some moon go in front of some planets.
Oh yeah, always is. Now, there's a link here. Let me just try.
I was on the wrong day. Okay, so yeah, it might be any time now. Possibility. So look it up online and see. You might be able, if you're like central. Well, you'd have to be somewhere just before sunrise. So wherever you're in the world, look before sunrise.
Since we're talking about gas giants, I'll just quickly go into this. This is a little video that just shows you how Jupiter does protect the Earth from asteroids. It's from the science page on Facebook. I thought I'd share that one.
Okay.
And what else do I have? I'm skimming through my Facebook quickly. Oh yes, they've imaged the polar vortex on Neptune.
On Neptune.
Yep. So
I see NASA's been working with the international weather, imaging the polar vortex over Michigan, which is where I'm at. So
okay, so what it is saying, Neptune has a polar vortex as well, as shown in the images. You can see the link in the chat room.
Yeah, I don't feel so
published
alone.
in 2006. Left is Saturn for comparison. Middle is Neptune in ethane band from the Gemini OBS 8 meter. Right is Neptune in near infrared from the Keck Observatory 10 meter, with a bright dot at the pole. Neptune needs a mission, and I totally agree with this. We need to visit Neptune. We need to spend more time at Uranus. They are the outer gas giants, and they are important pieces. They are important players in the Kuiper belt. Everything else outwards, including Pluto, which is still a planet to me, is a trans-Neptunian object, including Ultima Thule, Maya, and a few of the others out there that we actually know about. So going there, spending some time maybe at Uranus, for spending a couple of years at Uranus, then going on to Neptune, then we can do a lot more science. We are restricted because we're using ground-based telescopes. So yeah, Neptune and Uranus need a mission. But yeah, Cassie's right. We do. Only if we work together. This is where it all comes back to being a game, being a player in an international cooperation to do something major like science at Uranus and Neptune.
All right, getting down to the end. One last quick thing. Mars and Uranus are pretty much in conjunction right now. Not really close together, several degrees, but technically they're in conjunction. So get out there and do some observing. That's about it for us, everybody.
Captain Savick, this is the away team. Myself, Starstorm, and Marty are ready to beam up. Bring us aboard.
Sorry, I don't have any spaceship sounds this week. Thanks, everybody. Really appreciate all listening. And don't forget, we got more programming coming up, another 3-hour section. And then every 4 hours, we repeat everything for the next 24 hours. So you can catch us on repeat if you've missed any of this. Thanks, everybody that's been in our chat room tonight. Really appreciate it. Really appreciate you, Starstorm, Glenn, Cassie, everybody that's been here. All right, good night, everybody. Thanks again. See you next week.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.